Wait for it. What's going on, my peeps, my 7th grade peeps? And actually, this is 7th grade class. Let's get this part started. So, today, what we're going to do, I think peeps is your young word, kids word thing for people or children. But I guess you guys aren't really my peeps, right? Like, my peeps would imply that I'm a 7th grader as well. And I'm totally not a 7th grader. I'm like 3 times older than a 7th grader. Anyway, what's going on, my kids, my 7th grade childrens and whatnot? This is actually a repeat lecture from Wednesday where we did the lab and you guys came in and a lot of you folks were able to see it live. But what I'm going to do today is I'm going to re-go over it, but I'm going to go over it in more detail. I'm also going to cut out a lot of the times because essentially I'm making this as my way of making instructions for the lab. You guys know that at most of these labs I put videos up in front, which is really just pieces of the archive for this thing, and that's where I'm recording it. I'm recording it right now. So here's what we're going to basically be covering today. My goal for you today is to get you through an understanding of coordinate systems, particularly the Cartesian coordinate system. All right, the Cartesian coordinate system. I also want to do the distance formula with you. Before that, I forgot to write Pythagorean theorem. Which is a squared plus b squared equals c squared. And then the distance formula looks like this. D is equal to the square root of y2 minus y1 squared plus x2 minus x1 squared. Finish off that square root. You guys are like, oh my goodness, he's going math crazy again. And what I say to that is chill. Hey, chill. Just relax. Fine. You guys are freaking out? Fine, freak out. Go for it. You guys got your chance to freak out. LOL. I'm laughing on the floor and I'm laughing. I'm rolling all over the floor and I'm laughing out loud. Okay, all right. Stop freaking out. Time to chill. I already taught you this equation. You don't even know that I taught you this equation. I did such a good job at teaching it to you already. So don't freak out. Just write it down, okay? All right. And then the last thing I want to do is spreadsheets. Now, you're thinking all of this is math. What is he doing teaching math in our science class? Well, science is actually one of the best places to learn math because now you actually, not only do you learn math, but you actually learn, oh, that's why I would use it. I see a use for this now. Now I'm actually excited to learn this math because there's a point to this. It's not an equation he pulled out of the back of his pocket and threw it up on the board and said, memorize for this for the rest of your life. You see what I mean? In fact, I actually asked your math teacher to give you specific lessons to help support me in teaching you this type of math. So anyway, we're going to learn all of this stuff in the context of bridge building. So first thing you need to do, download a copy of the bridge building template from my Google Drive. And that bridge building template is very simple. It looks like this. And all it is it's a PDF file of you guys, of a graph paper, which I drew on. And it has your testing support. And since all of you read the rules for the bridge building competition, you know what this thing is. Your bridge is actually going to go slanted. This middle part over here, and I don't think I explained this very well in the instructions, but see this middle part between 0, 0 and 35, 0, that's all water. You cannot have pieces of your bridge going into the water. Let's make it a bottomless pit or something like that. Okay? So your bridge has to start on this side of the paper in this area, and it has to end on top of this area, and nothing can really be touching on the bottom in between. Does that make sense to you? You have to span that area. Are we cool? All right. So let me draw up a bridge. And before I draw up a bridge, let me explain to you what the Cartesian coordinate system is, because some of the 6th graders didn't know this, but I'm sure all of the 7th graders, I feel like you guys know this. You guys ever plot something with x and y coordinates? All right. When I showed this to Faustine, Faustine was like, "Oh yeah, I remember this. Why are we learning this if only some of us are participating?" What do you mean? Oh, well, Isabella, what you're asking for me is, why are we learning all of this stuff if only some of you are participating in the Science Olympiad event? Is that what you're asking? Okay, my answer is this: because the distance formula, all of these things that I covered over here, the distance formula, Cartesian coordinates, Pythagorean theorem, and how to use a spreadsheet is good for any science student. That's why. Because this provides fundamentals that all science students should learn. And if you don't learn it now, you're just shooting yourself in the foot for later. That's all I'm saying. So I'm trying to teach it to you now, because you're not only going to revisit this in science class, but you also revisit this in math class. In fact, math class even heavier than this, than in science class. When you first re-see this again. And what I want you to do is I want you to rock it in math class. And so I want you to actually see how this actually applies. And so you now know that, oh, this math that we're learning is not just this boring bunch of equations, but this is actually useful for something, like building a house or building a bridge or building, anything. You need to use these techniques. Got it? And yes, I am archiving this, assuming Snagit doesn't crash. All right. So let's build a bridge, basically using our thing. Oh, I was talking about Cartesian coordinate system. And the reason why we call it a Cartesian coordinate system is because it's in honor of a French mathematician, René Descartes. That was his name, Descartes, D-I-C-A-R-T-E, I think it was. But it was French, so it probably was pronounced like Descartes or something like that. I don't know. I'm horrible. I'm sorry. And what we do is it's kind of like playing the game of Battleship. We have an x-axis and a y-axis. The x-axis is horizontal. The y-axis is vertical. And if I wanted to describe a point like right here, and say this is like 1, 2, and then this is 1, I would actually describe it saying, well, how far, pretend I was an ant going from this point right here, which we call 0, 0, also known as the origin. It's where you start. And then pretend I was an ant and I needed to walk right and left. I can only walk right and left and up and down. Or maybe I was an ant being controlled by a video game controller, and you can only use the right, left keys and the up and down keys. Got it? So the first thing you need to tell me is, how far to the right do I need to go? How many times do I need to press the right button? This is 1, 2, 3, here's 4, this is 1, 2. How far do I need to press the right button? Not 4. Not 5. Come on. It's right here. I want to get to this point right here. 2 times. There we go. So the x-coordinate is 2 times because it always describes the horizontal distance first. How many times would I have to press the up arrow? Once. Very good. So my coordinates for this would be 2, 1, and I would always write, whenever I write the coordinates, I would always put x first and then the y. You guys got it? So my coordinates for this is 2, 1. Are we cool with that? Let's try another one. How's about so this is 3 and 4. This is 5, 6, 7, 8, 9, 10. All right, so let's pretend I go up to here. Right about here. What are the coordinates of this thing right here? 7 comma 4. Absolutely. And of course, we're assuming that Mr. Dolday actually drew something nice, right? So this would be 7 comma 4. So it would be, in order to get here, you would have to press the 7 right arrow, or you would have to press the right arrow 7 times, and you would have to press the up arrow 4 times, and you would get to exactly that point. And you always report the x coordinate first and the y coordinate second. Does that make sense? Okay, good. So then what I ask you to do is draw a bridge and make sure you label out each of the points. So you draw your bridge and say that it looks something like this. And then here's your testing block over here. And then what I want you to do in the instructions is mark out, all right, so you see, draw your bridge, you cannot draw in the XXX boxes, which basically means, see this area right here? Your bridge cannot go through any of this area right here, in this box right here. You guys got it? All right, what else do the instructions say? One side of the bridge is sitting on top of a testing block, which is on the right-hand side. We've already talked about that. The vertical line passing through the center of the page is, oh, hey, I got a phone call. Hello?
Hi, Mr. Dolday.
I'm actually in class right now. Can I call you back?
Okay, sure. Fine.
All right. I don't even know who that was. Oops. All right, well, don't call me during class. All right, so the center of the bridge, this center testing line is basically your center portion. And then what we're going to do is we're going to place a loading block somewhere around here. And then that's going to pull straight down on the bridge. So, let's see. Design your bridge and clearly mark out the nodes, labeling it the nodes with N0, N1, N2. So what that means is I have an N0, this would be one node, another node, which would be N1, maybe this would be N2, and then this would be N3. Nodes stand for basically, I don't know, connecting points, like that. And with each node, I want you to give me the coordinates of that node. So after you draw it on this piece of paper, you can basically read off your x and y coordinates. Got it? I don't know. Let's make up a few. Let's say that this N0 is actually at 0, 0, and we'll say N1 is at, I don't know, let's say 15, 10, and then we'll say N2 is at 25, 10, and then we'll say N3 is at 35, 5. Sound good? I'm just making it up. Okay. So, that's those instructions. Oh, and then the next part over here was it says connect the nodes with lines called members. So, I already did the connecting the nodes with lines called members. And so I want to label them. I'm probably going to call this member M01 because it's connecting node, which nodes? 0 and 1. There we go. Is there any work this week? Yes, actually there is work this week. I'm actually going through the work that you need to turn in for me this week. I'm basically teaching you exactly how to do it. So this lab is going to be due I think on Wednesday, and then the next one, or the spreadsheet is due. When is write it, do it, due? I'm going to probably going to make that due on a week that we're not as busy. I'm going to call this M12 and I'll call this M23 because this member connects node 2 and node 3. Does that make sense to you? Are we cool with that? All right. Then what I want you to do is use a ruler from your thing. Use a ruler and measure out the length that each of these things are in centimeters. I want you to take that number that you get, like say it's 10 centimeters or something like that, and divide it by the number 0.62. And then I want you to add up all of that stuff, and I want you to tell me what the total length of your bridge is. That's lab 1. Is that any questions, complications, vomits, etc.? Yes, Quinn, we did this at school. I'm re-recording the video because at school my computer crashed when it was trying to save the video, and all of that stuff that I explained went to trash. Yeah, sorry. No, I'm just going through this real quick. Also, not everyone was here, and yes, you need to be here because I'm going to be covering something new in just a second, or towards the end of the day, and end of class today. And new and very important. Okay? So, to do lab 1, you didn't need to know anything about Pythagorean theorem. You didn't need to know distance formula. All you really needed was to label all of the things and use a ruler to measure the thing out. How come I asked you to divide it by the number 0.62? Every single member by 0.62? Well, the reason being is because this piece of paper, when printed out, each of these things should be 1 centimeter big. Each of these little squares should be 1 centimeter by 1 centimeter. The problem is, if I did that, it wouldn't fit onto a regular sized piece of paper. So I had to shrink that I had to shrink the image down by 62%, or to 62%, so that it would be able to fit on a normal sized paper. So what you're doing when you divide by 0.62 each of those lengths is you're unshrinking it, kind of. You know what I mean? You're reporting what the unshrinked length would be. Does that make sense to you?
Mm-hmm.
So that's why you take all the numbers that you measure it, you use a ruler, you measure it out. Whatever that number comes up with, you divide it by 0.62. Then you add all of those up, and then you tell me what the total length of the bridge is going to be. We cool? All right. So I'm going to stop this recording. I'm going to start a new one, and we will get this party started on something.